Number 9. Mass excess of neutron over proton. If it were greater, there would be too few heavy elements for life. If it were smaller, stars would collapse, as neutron stars are black holes. But even in a universe fine-tuned at the cosmic level, local conditions can still vary dramatically. Think of the difference between Venus, Saturn, and the Earth. As it happens, even in this finely tuned universe, the majority of locations in the universe are unsuited for life. There are 12 broad, widely recognized fine-tuning factors required to build a single habitable planet. All 12 factors can be found together in the Earth. Number 10. Steady plate tectonics with the right kind of geological interior which allows the carbon cycle and generates a protective magnetic field. If the Earth's crust were significantly thicker, plate tectonic recycling couldn't take place. The Earth is largely protected from the solar rays through energetic charged particles emanating from the sun by its magnetic field, which deflects most of the charged particles. Without the magnetic field, a large number of solar particles will bombard the planet, increasing human exposure to higher levels of cancer-causing ultraviolet radiation. Number 11. Right amount of water in Earth's crust, which provides the universal solvent for life. Most human and plants have a tough time surviving without water for long. Number 12. Large moon with right planetary rotation period, which stabilizes the planet's tilt and contributes to tides. In the case of the Earth, the gravitational pull of its moon stabilizes the angle of its axis at nearly a constant of 23.5 degrees. This ensures relatively temperate seasonal changes and the only climate in the solar system mild enough to sustain complex living organisms. Number 13. The proper concentration of sulfur, which is necessary for important biological processes. Sulfur cycle, or circulation of sulfur in various forms throughout nature, makes sulfur available for life to function. Sulfur is one of the 6 basic elements for life and occurs in all living matter as a component of certain amino acids. Amino acids are the building blocks to life. They're important to cell integrity, structure, cell growth and repair, nutrition, absorption, energy production, muscle blood clotting, immune response, fluid balance, etc., etc. Sulfur is abundant in the soil and proteins through a series of microbial transformations and ends up as sulfates used by plants. Number 14. Right planetary mass, which allows a planet to retain the right type and right thickness of atmosphere. If the Earth were smaller, its magnetic field would be weaker, allowing the solar wind to strip away our atmosphere, slowly transferring the planet into a dead, barren world much like Mars. Number 15. The distance the Earth stays from the Sun in orbit around the Sun. It has a very narrow band around the Sun that allows life to flourish. It allows the planet to maintain the right amount of liquid water on the surface. If the Earth were just 5% closer to the Sun, temperatures could rise to nearly 900 degrees Fahrenheit. Conversely, if the Earth were about 20 degrees further from the Sun, it would become too cold for life and freeze. Number 16. The Earth has a low eccentricity, or a circular or even orbit around the Sun, which allows it to stay in that narrow life-giving band. If it were more erratic, it could form a more elliptical or oval-shaped orbit and pull itself out of that narrow band around the Sun. As discussed before, it's called Big Planet Orbital Resonance.
Today, we're going to talk you through a space phenomena known as orbital resonance. But first, we need to set up some basics. The Sun is at the centre of our solar system, and the Earth, other planets, and many additional bodies, such as asteroids, all orbit around it. As we head outwards from the Sun, we have Mercury, Venus, Earth, Mars, and then a big gap before we reach Jupiter. This gap is populated by the Asteroid Belt, a collection of countless lumps of rock, both big and small, and in all shapes and sizes. As we continue to head out past Jupiter, we pass Saturn, Uranus, and Neptune, and eventually reach another collection of countless bodies, the Kuiper Belt, which also houses Pluto. Orbital resonance occurs throughout the solar system, including shaping Saturn's rings. So let's look at what resonance actually is. There are a few different types of resonance that are all similar, but we're going to focus on just orbital resonance. Think of a person pumping their legs on a swing. They swing back and forth, but with each leg pump, their height or amplitude is increased. As a kid, you probably messed around with the timing too, like kicking at random points, which makes the swing go wonky, but doesn't affect the overall speed. This is similar to planets orbiting the Sun. If an orbiting body has no external forces applied to it, apart from the one keeping it in orbit, then it will continue to orbit at the same speed and frequency for a long time. If another planet comes close enough for it to feel an effect, then their gravities will give each other a little kick, much like the legs pumping on the swing. This can have an effect on the future of its orbiting movement. There can either be random orbits giving no overall effect, like the random kicks on a swing, or the planets are synchronized, and there can be periodic orbits, meaning that one planet can start to speed up as the other slows down. This is exactly how Neptune was discovered, where astronomers could measure something in the solar system giving little kicks to Uranus's orbits. Orbital resonances can destabilize orbits, causing the bodies to change their motions year by year until they are completely in a different orbit. For small bodies, destabilization is actually far more likely and results in a curiosity known as the Kirkwood Gaps. These are locations of gaps in the asteroid distribution, where asteroids have been ejected from these almost empty lanes by repeated perturbations from overlapping resonances. Sometimes an asteroid will pass too close to a planet and be ejected from the asteroid belt entirely. Many of these circumstances apply to the Kuiper belt as well, with the Kuiper belt existing beyond the orbit of Neptune, hence the common name trans-Neptunian objects. It too, like the asteroid belt, is a clustering of objects in an orbit around the Sun, but the area is much larger than the asteroid belt, extending over 1,000 times the size of the entire inner solar system. So orbital resonances can be seen as little tugs here and there, pushing and pulling the solar system's object into a more ordered state. And with this, Earth seems to have thankfully settled into a nice position and hasn't been ejected into space.
Even the orbital resonance between the Earth and the Moon is just right. If there is gravity pulled on the Moon harder, it could pull it out of its orbit and into itself. Any weaker and the Moon could float away out of orbit. It's rather like a lovely waltz around the Sun, along with the other planets. Number 17. A few large, Jupiter-sized mass planetary neighbors and large circular orbits, which protects the habitable zone of the Earth from too many comet bombardments. If the Earth were not protected by the gravitational pulls of Jupiter and Saturn, it would be far more susceptible to collisions with devastating comets. As it is, the larger planets in our solar system provide significant protection to the Earth from the most dangerous comets. Not all, but most.